Section 3.6, we're only going to do one example. However, this one example is going to take an entire page. So go get some paper and write down the title of this lesson. Go on. So 3.6 is solving systems of equations with three variables. Now, let's talk about the system. We're going to have 3x plus 2y plus 4z equals 11. Then I got 2x minus y plus 3z equals 4. Now, normally we've been solving systems with two variables and thus have two different equations. Now, because these have three variables, we're going to need a third equation in order to solve this. And the third equation is going to be 5x minus 3y plus 5z equals -1. All right, so this is our system. Now, this is a four-step process. Before we get started, what I'd recommend doing is naming each equation in your system. Now, you could call it Frank and Clyde and stuff like that, but for the sake of easiness, I'm going to call them A, B, and C. So we got equation A, equation B, equation C. Let's get on to step one. Step one, choose two of the equations. Choose two equations and eliminate a variable. Can't spell. Eliminate a variable. Now, you can eliminate any variable you like. You could eliminate the x's, you could eliminate the y's, you could eliminate the z's. Now, looking at this system, something might kind of jump out at you. You might notice that one variable is easier to eliminate than the others. If you ask me, the x's are all positive. You got 3, 2, and 5. You'd have to multiply. There's not a lot of common multiples there, right? Y's, you got negatives. You also got a 1y here. That could be useful. The z's, they're all positive. No common multiples. Z might not be a good choice. Oh, excuse me. All right, so we're going to eliminate these y's. So I'm going to take the let's start off with A and B. Now, the thing is, if I'm going to eliminate the y's using equations A and B, what do I got to do to B? I have to multiply it by 2. So, what I got here, A remains the same, 3x plus 2y plus 4z is 11. Then we got 2b, so that's going to be 4x minus 2y plus 6z equals 8. I'm going to multiply everything. So, when I add these up, I'm going to get 7x, the y's cancel, plus 10z equals 19. All right, so while we eliminated a variable, we still have two variables and only one equation. So we can't solve this further yet. Which brings us to step 2. Step 2 says we're going to pair. That's a P. Oh my goodness. Pair the third equation with another and eliminate. You might want to go and turn down your speakers for a second. The same variable. That is extremely important. The same variable. It's crazy important. That's why it's capitalized as though I were shouting it. In fact, I did shout it. Put some exclamation points after it and cube them. It has to eliminate the same variable. So, we used A and B. We have to choose C this time. We have to choose C. Now, we're going to eliminate the Y. So, Do you want to use A or do we want to use B when we pair it up with C? I'm going to use B. So we have to choose C. And I'm going to go with B, but what am I going to do with B so that I eliminate the Y? I'm going to multiply by negative 3B. All right, so C remains the same. It's going to be 5x minus 3y plus 5z equals negative 1. But negative 3b is going to be negative 6x plus 3y minus 9z equals negative 12. So when I add this up, we're eliminating y again. So we're going to have negative x, y's cancel, minus 4z equals negative 13. All right, again, we eliminated a variable, but we still have two variables remaining and only one equation. However, that's a similar story as it was in part 1, right? And that's what we're going to do. We're going to use the equations from steps 1 and 2, and we're going to solve that system. All right, so part 1 equation is this one here. So what we're going to do is we're going to pair up 7x plus 10z equals 19. That's the equation from part 1. From part 2, we're going to use negative x minus 4z equals negative 13. Now, I have two equations, each with two variables, so I can solve this system. I'm going to eliminate, what do you think I ought to eliminate? I'm going to eliminate x's, right? And in order to do that, I got to multiply the bottom by 7. Tell you what, go ahead and solve it yourself. Let's see if we agree. What is it? Negative 91, I believe. So when I add this up, x's cancel. I'm left with negative 14z equals negative 72. Excuse me, not negative 14, my bad. Negative 18z equals negative 72. Thus, z is 4. Awesome. So, z is 4. Great. But now we got to go back and find x. So I'm going to go back to this equation here, this system rather. I'm going to use the first equation. I'm going to do 7x plus 10 times z, the z is 4, plus 40 equals 19. Subtract 40. 7x equals negative 21. X is negative 3. All right, so we found x, we found z. However, we still got to do step 4. Step 4 is find the third variable. Step 4, we still got to find the third variable. So let's go all the way back to the beginning. We've got x and z. Now we have to find y. So which one do you want to use? I don't know about you, but I don't like, if I can avoid it, I don't like messing with negatives. So I'm going to go with equation A. Equation A is 3x plus 2y plus 4z equals 11. So I'm going to plug in the stuff that we found from x and z. So you got negative 9 plus 2y plus 16 is equal to 11. I'm going to move this way. 2y plus 7 is equal to 11. 2y is 4, thus y is, I'm going to put it here, y is 2. So now that I've got my 3 variables here, I got to write my final answer as an ordered triple. Our ordered triple is going to be -3, 2, 4. That's our final answer. Now, of course, there is a fifth step. Fifth step is to check your answer. You could go up here and plug them into all three of these equations, make sure it comes out. In this case, I'll save you the trouble. It does. So, tomorrow we'll talk about special cases, but right now, those are the 4 steps in order to solve a 3x3 system. Smith out!